Welcome back to Science Modernizers. Welcome back to this video. Today we are going to solve the Cameroon General Certificate of Education Board 2023 session. That's pure mathematics with statistics, question number 1. That's the full answer guide. So the first question reads, a polynomial p is defined on the set of real numbers r by p of x equals to 4x cubed plus 4x squared minus 11x minus 6. Given that 2x minus 3 is a factor of p of x, A. Factorize p of x completely, 5 marks. B. Solve the inequality p of x less than 0, 3 marks. Roman 2 says, the root of the quadratic equation 3x squared minus 7x plus 1 is equal to 0 at alpha and beta. Find the value of the expression 2 alpha plus 1 on beta plus 2 beta plus 1 on alpha, 4 marks. So let's get started to the video and get a proposed solution to this. Okay, so let's begin with Roman 1, that's the A part. So Roman 1, we have the polynomial p of x is equal to 4x cubed plus 4x squared minus 11x minus 6. Given that 2x minus 3 is a factor of p of x, factorize p of x completely. So here we have to express this polynomial as a product of its factors. So in order for us to do that, we are going to pass through synthetic or Euclidean division, that long division in simple terms. So the factor is 2x minus 3. And so what proves that this is a factor is if at the end of the division our remainder r should be equal to 0. That's from the factor theorem. So let's get that division and we actually verify that truly 2x minus 3 is a factor. So we have the polynomial 4x cubed plus 4x squared minus 11x minus 6. So this is divided by a linear expression of the form 2x minus 3. Now, so let's proceed with the division. So we have 4x cubed, we divide 2x. So what will be left is 2x squared. Now 2x squared times 2x will give 4x cubed. And 2x squared times 3 times negative 3 will give negative 6x squared. So we subtract. So we have 0 here, and here we have 10x squared. So we bring down this negative 11x. So do that again. We continue the division. Now 10x squared divided by 2x will give plus 5x. Now positive 5x times 2x will give 10x squared, and 5x times negative 3 gives negative 15x. So we simplify. So simplifying, we get 10x squared minus 10x squared gives null. Negative 11x minus negative 15x, this will give 4x. And so we'll bring down negative 6. 4x divided by 2x gives plus 2. 2 times 2x gives 4x. And 2 times negative 3 gives negative 6. From where we see that the remainder is 0, 0. Hence, 2x minus 3 is a factor of f of x. So of p of x. So since it is a factor of p of x, we have clearly verified that already. Now the essence was not for us to verify if it is a factor, but rather to factorize. And so in order for us to factorize, we are simply going to take the divisor and multiply with the quotient since the remainder is 0. And so generally, if you have a polynomial p of x which has performed division, it is always written by q of x, let me see, times certain g of x plus the remainder r, where we have, I can call q of x here my quotient, and I will call g of x the divisor. Okay, so when you take the product of the two plus the remainder, it gives you back the polynomial p of x. But in our case, the remainder is equal to 0, so definitely we are just going to take the product of the quotient and the divisor. That's 2x minus 3 times 2x squared plus 5x plus 2. So therefore, we get that p of x in factorized form will be 2x minus 3 times what we had as a result, that's 2x squared plus 5x plus 2. 2x squared plus 5x plus 2. So this is the first result. Okay, now we have factorized p of x completely. Now B says solve the inequality p of x less than 0. P of x less than 0. So we already have an expression of p of x. So let's go to the B part. So we are solving p of x less than 0. So we already have the expression of p of x in factorized form. So it makes it to be easier. So p of x less than 0 suffices for us to solve the inequality 2x minus 3 times 2x squared plus 5x plus 2 less than 0. So this means now at this case we are at this level, I'm just going to go straight to the critical values. So let's obtain the critical values for this inequality. So for critical values, we get that either 2x minus 3 is equal to 0, or we have 2x squared plus 5x plus 2 is equal to 0. So from here we get that x is equal to 3 divided by 2, or now at this stage we have to solve this quadratic. We are going to look for two numbers which when we multiply we are going to have AC, that's 2 times 2 which is 4, and when we add we have 5. So the two numbers are 4 and 1. So I'm going to express this quadratic in terms of 4 and 1, and below I'm going to drop the description link to the theory of quadratic equations if you have difficulties in understanding. So the two numbers which when we multiply we have 4 and when we add we have 5 are 4 and 1. So I'm going to express the number 5 in terms of 4 and 1. So it means this will be written as 2x squared plus 4x plus x plus 2 equal to 0. Now this can be factorized, so I can factor out 2x here which is common, and what will be left within will be x plus 2, then I have plus x plus 2 equal to 0. Now we see that x plus 2 is common. X plus 2 is common on both sides, so this means we can get 2x plus 1. I factored it out, then what will be left will be x plus 2 equal to 0. So there are two possible outcomes. So either so at this stage either 2x plus 1 is equal to 0, or x plus 2 is equal to 0. So we get that x is either equal to negative a half, or x is equal to negative 2. So those are the possible values of x. So the three possible values, the three critical values are x is equal to 3 divided by 2, x is equal to negative a half, or x is equal to negative 2. So we are going to represent this now on the number line. And since we are dealing with a strict inequality, we are going to use rungs to represent the points. So there are 3 points in total. Okay, so the smallest of the points is negative 2. Here we have negative half, and here we have 3 on 2. 3 on 2 is equivalent to 1.5. So I have the first region, region 1, I have region 2, I have region 3, and here I have region 4. So let us keep in mind that we are looking for the region where p of x is less than 0. In other words, let p of x less than 0 means the region where p of x is negative. So that's the region of interest. So we are going to begin with this. So let's begin by testing signs. Now in order for us to test signs, we are going to take any value below here and insert in p of x. So let us go back above. So let's choose a value. Let me write down p of x here to avoid going back above. So we have the polynomial p of x was 2x minus 3 times, I think that was 2x squared plus 5x plus 2. 2x squared plus 5x plus 2. Now we pick a value, let's say anywhere in this region, that's in region 1. So we can choose even -3, yes, since -3 is found there, and we plug inside here. So what we get is we have 2 times -3 minus 3. So we are interested in the sign at the end, into 2 into -3 squared plus 5 into -3 plus 2. So let's get the sign. Now 2 times -3 is -6 minus 3 gives -9. So we have something negative. And here what we get is -3 squared is positive 9 times 2, that's 18 minus 15 plus 2. So this will give us something positive. So something positive times something negative is something negative. So it means region 1 is negative. Now let's verify that of region 2. In between -1/2 and -2, we can get the point -1. So at the level of -1, we substitute -1 inside this polynomial. So what we get is we have 2 into -1 minus 3. So the first bracket gives us -5. So it's negative times, we replace it within. So we have 2 into -1, all of that squared, plus 5 into -1 plus 2. So this gives 2 minus 5 plus 2, which is -1. So -1 times -5 gives something positive. So this region is positive. So we continue the same. In between -1/2 and 3/2, 0 is there. So we are going to observe 0 here. If we plug 0, 0, 0, I'm left with -3 times 2. So which tells me that this region is negative. Now 3 and above, so I can replace even 10. So that will be 20 minus 3, and you have 10 squared, which is 100 times 2 plus 5 and whatever. So everything here is going to be positive. So it tells me here that this is positive. So that's it. So from here now we can state our solution set. Let me clean this. Okay, so from here we can now state our solution set. So the solution set, we are looking for the region that is negative. So the region that is negative, we have region 1, we have region 3. So how do we now state it? We see that it is all the values of x which are strictly less than 2, and all the values of x which are in between -1/2 and 3/2. So we get x is strictly less than -2, or x will be comprised between -1/2 and 3/2, and that is the solution to that inequality. Okay, so now let's go to the next part of the question. So the Roman 2 says the roots of the quadratic equation 3x squared minus 7x plus 1 equals to 0 are alpha and beta. Find the values of the expression 2 alpha plus 1 on beta plus 2 beta plus 1 on alpha. Okay, so we are at the level of the Roman 2 part. That's Roman 2. So the quadratic equation is 3x squared minus 7x plus 1 equals 0. So it's 3x squared minus 7x plus 1 equals to 0. And this quadratic equation has roots alpha and beta. And so we are asked to find the value of the expression 2 alpha plus 1 on beta plus 2 beta plus 1 on alpha. So let's simplify this. Now the first thing we have to do is we have to obtain the sum of roots and the product of roots in this expression. So from 3x squared minus 7x plus 1 equals to 0, the roots are alpha and beta, so we can obtain the sum of the roots. So the sum of the roots of the equation, it is given by alpha plus beta, which is negative b divided by a. So this will be equal to negative into negative 7 divided by 3, which will give 7 on 3. So we have 7 divided by 3, that's alpha plus beta, alpha plus beta. Okay, So from there we can also get the product of the roots. So the product of the roots is given by alpha beta, which is C divided by A. So this means that our alpha beta will be equal to 1/3, which is 1/3. And now we have to get the value of this expression. So let us simplify the expression on this side of the board. So we have 2 alpha plus 1 on beta plus 2 beta plus 1 on alpha. Now we are going to write down terms similar terms. So 2 is common. I can write 2 into alpha plus beta. So this is the same as 2 into alpha plus beta plus 1 on alpha plus 1 on beta. So on this side we observe that I can take the LCM here, which is alpha beta, and if I do that I have beta plus alpha divided by alpha beta, and so this expression is the same as 2 into alpha plus beta plus, since beta plus alpha is the same as alpha plus beta, so it can be written as alpha plus beta divided by alpha beta. So this expression in particular has already been simplified, but we know the values of alpha plus beta. So the values of alpha plus beta is 7 divided by 3 plus alpha plus beta, which is 7 on 3, divided by alpha beta, so that will be divided by 1/3. So that will be divided by 1/3, and so this will be the same thing as 14 divided by 3, that will now be plus 7 divided by 3 times 3 all over 1. So this gives 14 divided by 3. I will not simplify the 3 to simplify the expressions. That will be plus 21 divided by 3. So 14, simply add 14 to 21, which is going to give us 5, 3. So that's 35. So this means this will give us 35 divided by 3. So what does it imply? So this definitely means that the value of the expression, so therefore the value of the expression 2 alpha plus 1 on beta plus 2 beta plus 1 on alpha should give us 35 divided by 3. So that is the response to that question. And this brings us to the end of this video. Thanks very much for watching, and do not forget to like, share and subscribe to our channel. Stay tuned.